As you can see from the title of this lesson, this tutorial is about determining protons, neutrons, and electrons by looking at the periodic table. If we're going to discuss how to find protons, neutrons, and electrons off of the table, there's some other terms that we need to address so that we understand what they are and that we have them in our notes. The first one is what the various numbers that are on the table are called. You'll notice that every box on the table will possess three things, no matter what type of table that you have. Some tables may have 4 or 5 or 6 numbers. For instance, the one we have in our class has 1, 2, 3, 4, 5, 6 different numbers on it. Right? But even the simplest periodic tables will always have a symbol and 2 numbers, so there'll be 3 things. First thing, right, is called the atomic number. Right? The atomic number is the whole number on the periodic table. It is the whole number in a box on the periodic table. Atomic numbers go from lowest to highest on the table, so they start at 1 and it ascends all the way up to the heaviest of the elements, which actually on most tables will go all the way down to here into the 120s. But for the purpose of our table, I will say 107 because that's what's in class. Second number is called the average atomic mass. The average atomic mass is the other number in the periodic table. It is the decimal number. It is the decimal number in the box on the periodic table. The average atomic mass, we'll learn in a different tutorial, is an average of what? It's an average of all of the types of a particular atom that there are. We learned last chapter that not every atom of an element is the same. Sometimes they have different numbers of neutrons, and that makes them called something an isotope. So what happens is oxygen actually possesses 3 naturally occurring isotopes. One oxygen that has 8 neutrons, one oxygen that has 9 neutrons, and one oxygen that has 10 neutrons. So what happens is, to get the number for what an oxygen atom weighs, we have to account for the fact that there are 3 different isotopes, and we have to take an average of those isotopes. That is where the decimal number comes from, but for what we're talking about here, all you need to know is the decimal number in the box is the average atomic mass. Be aware as you go farther down the table with the larger elements, like astatine, radon, polonium on some tables, it will be a whole number like 210, 210, 222, and it's in parentheses. The fact that it's in parentheses tells you it's the average atomic mass. The smaller of the 2 numbers in the box will always be the atomic. Last but not least, you have something called the mass number. And the mass number tells us the number of protons and neutrons. It tells us how heavy the nucleus of an atom is. So the mass number is the decimal number rounded to the nearest whole number. The mass number does not appear in the box unless it's one of these very, very heavy ones. Like the 222 is a rounded number for what radon's average atomic mass is. We will use the mass number to get protons, neutrons, and electrons. That is why we have to know what it is. So if I looked at an element off of the table, for instance, we looked at selenium, every table will be different. Sometimes the tables will have the whole number in the top left, the decimal in the top right. Sometimes they'll have the whole number in the top right, the decimal underneath. Right? So it will move around, and I will move our examples numbers around so that you get familiar with working with different periodic tables. If I'm going to identify these, the first thing you have to know is the letters in the box are what we refer to as the nuclear symbol. Nuclear symbol tells us who the element is. I don't need the word selenium down here because Se tells me it is the element selenium. Most often we'll refer to this as just the symbol. What is the element's symbol? Now we have the two numbers. Right? We have our whole number and we have a decimal number. Well, like we said up here, the whole number, this one here, is our atomic number. Right? Whole number that's on the table. Right? The decimal number that's in the box, this one here, right, is our average atomic mass, so we will label it as such. So why is it important that we know what these are called? The reason it is important is because the atomic number and the average atomic mass are able to tell us about the number of protons, neutrons, and electrons that a particular element possesses. And that's very important because the number of electrons determines how an element reacts, and the number of protons determines who the element is, who is their identity. So, how is it that these things link up to the protons, neutrons, and electrons? You can take a look here. These are our general rules for identifying how many protons, how many neutrons, how many electrons. Here's what this says. Right, the number of protons in an element is equal to the atomic number. And if you remember from the last board, the atomic number is the whole number. The number of electrons is equal to, again, the atomic number, the whole number on the periodic table. So that means that the protons and electrons in an atom of an element are always equal. The reason for that is that all elements on the periodic table, right, are chemically neutral. Right? They have no overall charge. If they get an overall charge, we don't call them elements anymore, we call them ions. So the protons and the electrons are always equal. They're equal to the whole number on a table. The neutrons you have to do a little bit of work to find. The neutrons are contained in the nucleus with the protons. So what happens is we need to take the mass number, which is how heavy the nucleus is, minus the part we don't want, which is the protons, and that will get us the neutrons. So the mass number is that decimal rounded minus the whole number, the atomic number. So you'll have to do a subtraction problem to get yourself the neutrons. So let's go through a series of examples, and we will find ourselves the protons, neutrons, and electrons of an element. First element we're looking at is oxygen. If you notice, I made this one look different than the periodic table here. Oxygen here has the 8 up here, 15999, and the word oxygen. Here, I just put the 8 here, the 15999 underneath, and our symbol. It does not matter. The only thing you have to understand is which number is which. If I want the protons, I need the atomic number, which is the whole number. The whole number on the box here is an 8 and a 15.999. 8 is the whole number. That means that oxygen has 8 protons. Notice, next to the proton, I have a positive sign because protons are positively charged. Next up, the electrons. Electrons are also equal to the atomic number, so I have 8 electrons. So what you'll notice is my 8 positives and my 8 negatives cancel each other out. Last but not least is my neutrons. I need to take the decimal number rounded minus the whole number. Here is my decimal number, 15.999. If I round it, it's 16 minus the whole number, which was 8. That means that oxygen has 8 neutrons. Right? And notice there's a 0 above the little n for neutron because neutrons have no charge. This will not always be the case that they all match 8, 8, and 8. You'll find that that is pretty common for elements in the first 2 to 3 rows, but as you push down the table further and further, you will see that the neutrons tend to exceed the protons and the electrons as we go. Right? So the protons, atomic number, electrons, atomic number, and you do a mini math problem to get your neutrons. Right? Let's take a look at a couple more. Example 2. Right? Let's look at the element rhenium. Right? Rhenium is right here on the periodic table, Re. Right? And if you looked at your table, or you can read what this says here, right? We have Re 75 and 186 is our numbers, 0.2. So if I want the protons are equal to the atomic number, which is the whole number. That's the 75. That means we have 75 protons. Electrons and protons are always equal because they're both the atomic number. So we have 75 electrons. Okay. To get the neutrons, I have to take the decimal number rounded minus the whole number. So I'm going to take 186 minus 75, which looks like it's going to be 111 neutrons. So pretty straightforward, right? Whole number is the protons and the electrons. Neutrons, this number minus this. How about we look at something like thallium? Right? Thallium is right here on the table. Right? Tl. Right? Its numbers are 81 and 204.4. Right? So the protons would be equal to the whole number, which is 81. The electrons also equal to the whole number, which would be 81. And the neutrons will be the whole number subtracted from the decimal number rounded. So we're going to take our 204.4, which will round down to 204, minus 81. 204 minus 81, right? Take 4 off of this, that would put us at 200, which means we're taking 200 minus 77, which looks like we'll have 123. So, 81 protons, 81 electrons, 123 neutrons. Sometimes people tend to ask, well, what if this number is like 204.5? What if it's exactly a 0.5, right? Do we round it up or do we round it down? The answer to that question is it won't ever happen, right? You will never find an element on the table that is exactly like 0.5000000. It will either be like 204.51, and if it's above 50, it will round up. If it were 204.9, okay, that would round down. Right? So you'll never have a case where it's exactly in between the two numbers. So that's one thing you can do. The other thing that you'll see is instead of being given all of the pieces of information, right, in finding these, what they'll do is they'll ask you to identify an element based on the things you see in the table. For instance, if we looked at these ones, up here it wants me to identify the following element. Simply tell me who is the element that possesses these characteristics. The easiest way to figure out who elements are is always the whole number, the atomic number. Here is why. Right, the whole number, right, are in ascending order on the table. So if I get a whole number of 7, right, I know the table starts at 1. I just go 1, 2, 3, 4, 5, 6, 7, and I know that I've hit that element. If you want to search for all the decimal numbers till you hit 14.01, you can. It just takes a little bit longer. Right, so sure enough, if I go 1, 2, 3, 4, 5, 6, 7, that means that X represents nitrogen. If we do the same thing for this element here, I can either search all the small decimal numbers for 126.9, or I can look for 53, and sure enough, if we keep looking, 30s, keep going, 40s, 52, 53, and it looks like it is iodine. The last thing that you may have to do is, given a box on the table, fill in the blank. So you're still solving for x, except it may or may not be the element symbol. It could be another piece of info. For instance, if we look at this element here, they want me to either list the atomic number or the average atomic mass. So we look at the symbol, we find polonium, which is right here. On our table, polonium has 84 and 210. Well, the 84 is already here, therefore x must be the average atomic mass, which was the 210. Doing the same thing, we take a look at sulfur. Sulfur is right here. It's got a 16 and a 32.06 in the table. 3206 is there, which means the x must represent the atomic number, which is the 16. Last one, a little bit of a trickier one. What happens if they're both whole numbers, right? And I'm looking for the element. I have 86 and 222, so I can't find it on the table, all right, just by looking for the symbol. You have to remember, the smaller of the two numbers is always the atomic number. So the 86 is the whole number. 222 is just one of those ones that gets rounded because it's large. All right, so we would look for 86 on the table, and if I scan, sure enough, there's my 86. All right, Rn is radon, so this would be radon. So that's all there is to it. For working with protons, neutrons, and electrons, you can simply use the periodic table, and remember the whole number is the protons and the electrons, and the decimal number minus the whole number are your neutrons. If you have any questions, please come in for some help.